Hey there and welcome. Have you ever just stopped and wondered how your phone knows your face? Or how a chatbot can somehow write a pretty decent poem? You know, it can feel like straight up magic, but it's not. It's actually a really fascinating process of learning. So today, we're going to pull back the curtain and take a journey deep inside the mind of a machine.
All right, so let's get right to it. The big question is this: how does a machine actually learn to see, listen, and understand the world around it? I mean, it doesn't have eyes or ears like we do, so how in the world does it make sense of all that raw information?
Well, the answer lies in this really powerful idea that's actually inspired by our own brains, the neural network. These networks are amazing because they can learn directly from data. We're talking images, text, sounds, without anyone needing to program in a bunch of rules. And this is the core tech that powers pretty much everything from your photo app to massive AI models like GPT.
Okay, so to really get a handle on a neural network, the best way to think about it is like a team of decision makers. So let's go ahead and meet the key players. First up, we have the input layer. Think of this as the network's in-tray, or its front door. So say we're showing it a picture of a cat. Every single pixel from that picture, it all enters the system right here. This is the starting line for all the information. All right, once the data's in, it moves on to the hidden layers. And this is where the magic really starts to happen. It's the engine room of the whole operation. Inside these layers, millions of tiny calculations start firing off to find patterns. You know, things like, is that a whisker? Are those pointy ears? This is where all the heavy lifting goes down. And then, at the very end of the line, we've got the output layer. After all that hard work in the engine room, this layer is the one that makes the final call. It takes all of that incredibly complex pattern finding and just boils it down to one simple, clean answer, like a label that says cat with 95% confidence. But wait, how do these layers actually make their decisions? Well, each one of those tiny decision makers, we call them neurons, uses two really basic tools. First, there are weights. You can think of these like volume knobs that decide how important one piece of information is. And then there's bias. This is more like a little nudge in one direction or another, just to help fine-tune the final decision.
Okay, let's zoom in even closer. Let's look at just one of those neurons and see how it thinks. And believe it or not, it all comes down to a really simple calculation.
So every single neuron, no matter where it is in the network, follows the exact same three-step process. First, it takes its inputs and multiplies them by their weights to figure out what's important. Second, it adds that bias we talked about just to fine-tune things. And then, for the final step, it runs that result through something called an activation function. This last step is super important. It's what allows the network to learn really complex stuff, not just simple on or off things.
Yeah, and you can see that process right here. I know it might just look like some simple math, and honestly, by itself, it is. But here's the kicker. When you get millions or even billions of these neurons all doing the same simple calculation and passing the results to each other, that's when the network can suddenly start to recognize incredibly complex patterns.
So that activation function I mentioned, that's really the secret sauce. You see, without it, a neuron is basically just a light switch. It can only be on or off. Simple, right? But when you add that activation function, it's like turning that light switch into a dimmer switch. Suddenly, it can have all these in-between values, these nuanced outputs, and that's what lets the entire network learn subtle and complicated things, like the curves of a face or even the structure of a sentence.
Okay, so we've met the players, we've seen how a single neuron thinks. Now let's zoom back out and see how the whole team works together to make its first guess. This whole process has a name. It's called forward propagation.
The best way to picture it is like a wave of information just flowing forward through the network. So our cat picture goes into the input layer. Then boom, the neurons in the first hidden layer all do their calculations and fire, passing their results on to the next layer. And then those neurons fire, and so on, like a chain reaction. The information gets transformed a little bit at each step until finally, it hits the output layer, which spits out the final prediction.
Okay, that all sounds pretty neat, right? But there's a catch. On its very first try, the network is basically just guessing. I mean, all its weights and biases are set to random numbers, so it has no idea what it's doing. So what happens when it looks at our cat picture and confidently says, that's a dog? How does it even know it's wrong? And that right there brings us to the most magical part of this whole thing, how the network actually learns from its mistakes. And to do that, it has to go backward. Okay, so the first step in learning is you need someone to check your work, right? A manager, basically. In a neural network, that manager is called the loss function. Its entire job is to look at the network's prediction, dog, and compare it to the correct answer, which is cat, and then calculate an error score, a score that says exactly how wrong it was. And the whole goal of this entire training process is to get that error score as small as possible, as close to 0 as we can get it.
This leads us to the absolute climax of our journey, the main event. It's called backpropagation. So once that loss function calculates the error, it sends that error signal backward through the entire network. This signal basically tells every single neuron, hey, you were this much responsible for the final mistake. And then armed with that feedback, each neuron makes a tony adjustment to its own weights and biases. It's like it's saying, all right, got it. Next time I'll tweak my settings just a little bit to get us closer to the right answer.
And here's the most important takeaway. Learning isn't a one-and-done thing. It's this constant cycle. Predict, measure the error, correct backward. Predict, measure, correct. Over and over and over again. This predict and correct loop happens thousands, sometimes millions of times. And with every single example it sees, the network gets just a little bit smarter, a little more accurate. So there you have it. We just walked through how a pretty simple network can learn something as basic as telling a cat apart from a dog. So I want to leave you with one final thought to chew on. What happens when you take this exact same process, but you scale it up? I mean, way up. Billions of neurons, learning from the sheer, unimaginable vastness of the entire internet? Well, that is how we get the jaw-dropping AI we see all around us today. Thanks so much for joining me on this journey.